Hey everyone, welcome back to the Physics 30 videos. In this video, we're going to look at Unit 2 on force and energy, and here we're going to be looking at Newton's three laws. So Newton has three laws of motion. The first one is the law of inertia, which basically says that an object at rest tends to stay at rest, while an object in motion tends to remain in motion unless any of those objects are acted upon by some sort of outside force, like maybe you're pushing a desk around a classroom. So right now, you might, as long as you're putting no force, that desk is going to stay there. But as soon as you start to push it, then it's obviously going to move in some sort of direction. So Newton's second law states that when a net force acts on an object, it accelerates in the direction of the net force. And so this one here actually has a formula that we can use. And so this one here is your force is equal to your mass times your acceleration. And so from this equation, we can see that if we want to compare our acceleration, so say if we were to manipulate that equation, we'd have acceleration is equal to force over your mass. Then we could see that your acceleration varies directly with your force. So if you increase your force, you increase your acceleration. So acceleration also has this inverse relationship with your mass, where if you increase your mass, you decrease that acceleration. So then moving on to Newton's third law of motion. So this one here says that every action has an equal and opposite reaction. So an example of that might be, say, even a stationary object, like maybe, once again, your desk in a classroom. So if you're not, as long as you're not touching it, it looks like it's not moving. So what happens there is that it's not moving because basically your forces are all equal to each other. Because we know that there is a force of gravity, so why isn't it going through the floor and going straight through down to the earth, to the center of the earth? And that's because there's some sort of normal force that's equal in that, equal to the force of gravity, which is why it's not moving up or down, it's not floating out in space or going straight through to the center of the earth. So that one there has that equal and opposite reaction. So we're going to look at an example from your notes, which is number 3 from the first section of your notes. So Cynthia's bowling with her classmates. She gives a 6.0 kilogram bowling ball an acceleration of 4.5 meters per second squared forward. Here we're going to calculate the net force she exerted on the ball. So here I'm just going to write down all the information that we're given. So here we're told the mass of our bowling ball. So your mass is 6.0 kilograms, and your acceleration is 4.5 meters per second squared, and our direction here is forward. So here we're looking for that net force, and so with this one here we can use that force is equal to mass times your acceleration that we had given in your Newton's second law. So here we're solving for F, so we're going to put in 6.0 in for M, and 4.5 in for your acceleration. So if you multiply those two numbers together, you should get 27, which does, once again, account for our significant digits, because here we have 2 significant digits, here we have 2 sig figs, so our answer there should have 2 sig figs. So here we have 27. We also do need to talk about our units, and we need to give it a direction because your force is a vector quantity. So our units for force are newtons. And the direction is the same as your acceleration, so it should be forward here as well. So this here is our force, and this one here was a word problem, so we do need to make sure we write a sentence with that. So we could say that the net force exerted by Cynthia is 27 newtons forward. So just to recap that, so just remember that your force is a vector quantity, so we do need to make sure we have a direction attached to that as well. And then just make sure to write your sentences for any of your word problems. So that is everything for this video. So if you guys have any questions, make sure you come see me in class. You can text me on Remind 101. And thank you guys so much for watching.